Well, good afternoon, good morning, good evening, everyone, and welcome to our 183rd Reading Online Sports Economics Seminar. For better or worse, you have me presenting this week, and I will start my presentation shortly. At least it means this week, if I waffle on with administrative notices, I'm only taking away my own time rather than someone else's time. But to say, our seminar series is hosted by the University of Reading. And is generously sponsored by the Sports Economics Review. I will aim to be done within about an hour, and there'll be plenty of time for questions and comments, and I will certainly invite plenty of questions and comments. This remains ongoing work, although I'd like it to be a bit more developed than it is, but it is still ongoing work for the time being, and I'll certainly be grateful for any comments. Let me try and share my screen. So there's the view and full screen. The title's slightly amended from what I listed. So I listed just simply Elo-based player ratings. But I think a preliminary step is to think about how good Elo ratings are. And I was Vincenzo, in his talk the week before last, very generously referred to me as being an expert on Elo ratings. I certainly use them quite a lot, and so it probably makes sense if I try and pull together some of the information that have pulled together over the years using Elo ratings. I should also say this is heavily related to work that I've been doing with various people on slightly different aspects of Elo ratings. So I've listed there Stefan Szymanski, Carl Singleton, Luca De Angelis, and Ed Wheatcroft. There's probably others as well. And the real challenge for me is to try and get these things out and into print where they should be out and in print. Before that, I want to flag up a event in February. So you'll have seen in the reminder, in the reminder email sent out this morning, a list of forthcoming events with mainly the talks that are scheduled until Christmas, and there will be talks after Christmas as well. But there's also a number of conferences coming up in the new year, and not least Dennis is organising a conference in the University of Baltimore. And there's the usual Gijón conference, and the European Sports Economics Tour will be in Duisburg again, and there'll be a conference in Pau in the Pyrenees as well. But I want to flag up the conference that I'm involved in organising. It's going to be at the stadium that is behind me in my location. It's Oldham Athletics ground, and there's a heavyweight lineup. Some of these are to be confirmed, but we hope to have Kieran Maguire, whoever people will know as the Price of Football author and podcaster, and also a professor at the University of Liverpool. We'll have Christina Philippou, Jack Coles, who works at Lincoln City, Stefan, Alex as my fellow organisers, and as the editors of the Sports Economics Review, which is sponsoring this conference, as well as the University and Oldham Athletic. There'll also be talks from David Forrest, Tony Collins, and Darren Royal, who is Oldham's CEO. So there's plenty to look forward to there. I've been trying to get the photo of Boundary Park onto the poster, but it's quite subtle. So I wanted to share the photo as well of the venue of the conference. It's not in a standard academic environment. It will be in this rather the better looking part of the stadium. Other parts of it do look a little bit like they're showing their age, but this part here is quite recent, has conference facilities, and so please do give some thought to that. February 14th and 15th, culminating in a game on the Saturday afternoon at Boundary Park. So that's a conference for you to look forward to. So Elo ratings. And the plan for my talk will be essentially to talk a little bit about what they are and think a bit about the parameterization of them. And then think a little bit kind of alongside that, how good are Elo ratings? And then the final step, assuming we get there, is deriving player ratings from them. And I'm pleased to see a lot of folk in the audience who are not from the economics profession, statisticians, mathematicians, etc. So I'll be delighted to get input from various folk along the way today. This is an economics talk, and I'm quite happy to motivate why it's economics, but we are, of course, drawing on lots of statistical methods here. And so it'll be great to get the input from others. So what are Elo ratings? It's a rating system devised by Mr. Elo himself, Arpad Elo, in 1978 in his book. And they assigned strengths to each participant in a contest. They were devised for chess, and they've been applied across many sports. And a quick Googling, you find lots of Elo ratings, websites with Elo ratings for football teams, for national teams, obviously different sports as well. And many sports have adapted their official rankings to look a bit more like Elo ratings, I guess, a testament to the value perceived in these ratings. They are essentially the ratings are assigned to the two competitors or two teams in our context, at least in the first instance, Team I and Team J, and then the difference between those two teams and their ratings helps to form a prediction for a game between the two teams that might be taking place. And this prediction, EIT, from the perspective of Team I, lies between 0 and 1 because it is it's a logistic curve, and what I've varied here is this what's called what's sometimes referred to as the K factor. 1 over 400 is what's conventionally used, or at least that's what's listed on the Elo Wikipedia page as the standard method, and that would be the black line here. So you can see that this little k dictates the slope of the logistic curve around 0, where on the horizontal axis we've got the difference in the Elo ratings between teams. So if we had two teams with a 200 Elo rating difference, that would yield a different prediction closer to 1. The smaller was the little k factor, and so it's an indication of the sensitivity of the ratings to differences between sensitivity of the prediction to differences in the Elo ratings. And so it's logistic curve. So by design, these forecasts should be EIT rather than X. But EIT is between 0 and 1. And we can think about the equivalent prediction for the other team, Team J, being 1 minus the prediction for Team I. And then the ratings are updated. So I've got my Team I at time T, and then I want to find what it is after the game that takes place. And I look at the difference between the outcome, which I haven't set out here. I don't think I do in the slides at all, no. So the difference between the outcome, which would be a 0-1 variable if we had a sport without drawn outcomes, minus the prediction. So the idea here is that the size of the adjustment is proportional to the, if you like, the impressiveness of the victory. If a team is not expected to win, then EIT of Team I is not expected to win, then that would be a small number, say 0.1. And if they won, this would be a 1, and you get a 0.9 for your adjustment. Whereas if Team I was expected to win, and say they had a 90% chance, and therefore EI was 0.9, this would be a smaller amount. And so the Elo ratings would adjust by a smaller amount, exclusive of the choice of K. K factor is what people spend a lot of time thinking about, and a lot of the different rating systems online and around that exist differ in their choice of big K. Obviously, big K and little k both relate to the sensitivity, whereas big K is the sensitivity of team ratings to match outcomes in relation to the prediction, whereas little k is the sensitivity of the prediction to the differences in team ratings. So just to illustrate Elo ratings, again, this might be painful for those who are very familiar with them, but this is an example of my team, again, so heavily promoting my team today, but this is their first recorded match in the FA Cup in 1907. And so because it's their first match, they have to start somewhere. So convention is individuals start at 1,000, for better or worse. And the hope is that quickly, with lots of games, a team's rating will reflect their true strength because they're winning and losing against teams with their own ratings. And so there's a calibration process that takes place. In this particular case, because Oldham were playing in regional football at the time, they weren't in the Football League. The only games that we have in the recognised sources of data are the first round of the FA Cup, where they beat Kidderminster, and the second round of the FA Cup, where they were beaten by Liverpool. So Oldham played their first match with a rating of 1,000. They played Kidderminster, who played one match previously in a previous round of the FA Cup years before, and so they had a slightly less than 1,000 rating because they lost that game. Prediction was 51. Oldham won 5-0, which suggests that maybe they were slightly better than evens with that team. And so they progressed to the next round, where they were beaten by Liverpool 1-0. Liverpool had already been in the Football League for a number of years at this point, so they had an Elo rating of 200 better than Oldham. And so the rating was 0.24 from Oldham's perspective. And those are the two matches up until that point. In the summer of 1907, Oldham were admitted to the Football League, and so they began to play regular games. So our point here is that Elo ratings are only as good as the data that you feed into them. And so Oldham's rating likely better calibrated to what it should have been once they entered regular recognised football where the data exists. One final thing to say, and I'm not going to spend much time on it today, is that there is an issue with the fact that in football we have the drawn outcome. So this Elo prediction would be between 0 and 1, and just because it's 0.5 doesn't mean that the other team has a 49% chance of winning. What I've done here is I've used an ordered logit model to generate some probabilities, and we have the Oldham were about 50% to win when their Elo rating was 0.51. But Kidderminster were only about 25% to win. And equally well, Oldham still stayed at 24% when they had an Elo rating of 0.24. And that meant that Liverpool were actually about 51% to win the game. And so then Oldham entered the league, played lots of games, adjustments up and down, whether they when they won and they lost games. And so that's a picture of the same thing, where we've got a long period where there's nothing much happening with the Oldham's Elo rating, but then regular updates, and the Elo rating climbs after wins. So a blue square is a win, climbs after the wins, and falls down after the red triangles, which are the defeats. And sometimes does a bit of both with the draw, depending on whether the draw was a good draw or a bad draw. The outcome variable is 0.5 for a draw. And this is something that previous studies that have looked at Elo ratings have assumed. So 1 for the home win, 0.5 for the draw, and 0 for the away win or the defeat, in the case of thinking about it from Oldham's perspective here. And of course, once you start to calculate these kinds of ratings, you can do them for all sorts of teams. They can be teams that are in the same competition, but they can be other teams, much bigger teams. And here I've put Oldham's first few games here, but of course Oldham have carried on playing football since. And I've put on here as well Manchester City, who I can't remember. I don't know when they became Manchester City from Ardwick, and Man United. I don't know when they became Man United from Newton Heath, but they were both already more established football teams when Oldham joined the Football League in 1907, and Newcastle United as well. One thing it's not so easy to see. I'll see if I can zoom in. Here we go. One thing you can see. I can't go. Yeah, there you go. I can go a bit further. The First World War was a terrible event for many, many reasons, but not least it destroyed a pretty good Oldham athletic team who almost won the league championship in the 1914-15 season. What else to say about these ratings? If this is a useful rating system, in principle, then we might be able to use it to think about comparing teams across each other. So I've tried to do a comparison there by saying that of these 4 teams, Oldham were the best in 1915. And obviously Man City, despite their recent blip, are still the best at the moment. But maybe can we compare across time? And can we compare across competitions as well? We have league standings that enable us to make comparisons of teams and strengths of teams. But maybe there are flaws in league standings that we might want to think about, to evaluate. Question is, if Elo ratings are useful as a measure of team strengths, they might enable us to make a lot of different types of interesting comparisons. That would be the current top 10 in terms of Elo ratings, and most of it would probably make sense. And these are Elo ratings that I've calculated, and you'll understand. And the method, the parameterization, I'll set out in a little bit. But based on that parameterization, the top teams are roughly speaking what you'd expect. But then the interesting thing, if you do calculate this, is you can calculate these ratings for any team in any division, any competition, and you can drop down to say positions 53 down to 62. And when you get to this point, things start to look a little bit unexpected. There's Oldham again. Oldham one position behind Reading, where Reading are actually two divisions higher. They're in League One at the moment, but they had a poor season, or a number of poor seasons on the bounce. They're doing a bit better this season. They're in 7th place in League One. And then you've got Preston in the Championship, but near the bottom of the Championship. You've got Macclesfield Town, who are actually in the 7th division currently, but they are top, and they have been doing very well after they went bankrupt and reformed. And then another team from the lower division, Worthing Football Conference or National League South. That's the 6th division. Luton Town were in the Premier League last season, or in the Championship. So you start to see quite a mix of teams and provocative mixes of teams. And so then that really begs the question, are these really ratings that we should put any of our trust in? So what we'll do is we'll use lots of data. Obviously, I've shown you some data. We'll use data so long as we've got essentially teams taking part in a game, the date the game took place on, the competition it was in, because we might want to tweak the ratings based on the competition the game was in. And so long as we've got the goals for each team and hence the outcome, we can construct Elo ratings. We can construct them as far back as we want to, or we can start in different places depending on what we think is best. Later on, I'm going to motivate an idea of player Elo ratings, and for those, what we need on top of simply having the teams and the dates, competition, and the goals for the result is we also need who played, the lineups to start the match, the substitutions, the timings of the substitutions as well, who scored the goals, and if players were given disciplinary sanctions. It might be fun to also have other player profile information, but that isn't necessarily essential for creating player ratings. The data mainly comes from Soccer-based. I've got some betting prices from footballdata.co.uk to evaluate. You can see I like football web pages so much that I've included the link twice, but that's a good source of non-league results, plus lineups down to 2 or 3 divisions below the Football League, which could be useful. And then Transfermarkt is obviously always a solid source of information, and often goes down below the National League, so it goes into the 6th division in England with lineups, goal scorers, and so on. And I'll just skip past the next couple of slides. So with this Elo rating, we need to choose parameters. So I mentioned I set them out, and particular people have chosen particular choices. Apparently, Elo himself proposed that for weaker players beginning in the game, that K would be 32, and then for the best players, the masters, that they would have a K of 16. And obviously, the more data there is and the more sports, the more we can think about evaluating what is the best possible rating, essentially based on observed outcomes. And so there's been work on chess over the years, and there are still different ratings proposed, as I understand, where some will have a higher adjustment factor for the quality of players, as we have this idea here, or the converse of this idea here, or others will have higher ratings for perhaps the first few matches, allowing a more speedier calibration, perhaps. There's a couple of football-related websites here, where Elo-ratings.net gives you national football team ratings, and they have a system where their K factor is 60 for the World Cup, and then down progressively to 20 for a friendly match, signifying that World Cup matches are more important, therefore they should be weighted more highly. Club Elo ratings, they say they have a K of 20 throughout, but a principle of the most important matches getting the highest weights might suggest that with club Elo ratings, league matches might get the highest weighting because, well, the league tends to matter most to teams, with perhaps the exception of maybe the Champions League. But that would suggest that league matches might get a higher weight than some cup matches at any rate. So as a kind of initial attempt to try and shed a bit of light on this, I've calculated Elo ratings for the history of English football, essentially, and done it with a different set of these parameterizations. And given that the big K and little k relate to both relate to sensitivity, as you can probably imagine, some combinations of these are equivalent to each other. And you'll be able to see that on the table that I produce in a moment. And the idea essentially is generate Elo ratings with these different parameterizations, not that many of them, certainly not as many as Lars Fathom in his paper did, but try and evaluate them based on Brier scores I'll present here, and then a quick look at the idea of forecast efficiency as well. Another way of course, trying to evaluate ratings is to simulate the situation. So obviously we observe lots of football, but we don't know the true strengths of teams involved. We don't know when the strengths of teams changes when we're watching or when we're thinking about football or any sport in the real world. And so a simulation allows us the possibility of essentially setting what our team strengths are. We design what the world is, and then we generate lots of replications of this same world that we know what it looks like, and then we observe the behavior of our Elo ratings, say. So simulations is another way in which we might try and evaluate different parameterizations when it comes to Elo ratings. I've had a start at doing that whilst I've been preparing for this talk by generating a two-team competition where in the first simulation, the two teams are equally have an equal strength, and there's a small home advantage. And I calibrate that by the expected goal arrival and generate goals according to a Poisson distribution. So that's obviously only one way in which you might generate a simulation, and it's what I've done so far. And so essentially it generates such that both teams are of equal strength. They start on an Elo rating of 1,000, so therefore you'd expect them to, probably if they're both equal strength, their strength essentially is 1,000, it should stay at about 1,000. And this is based on, oddly, 109 replications so far. And these are per match across 400 matches simulated from a Poisson distribution, with the home team being slightly stronger, and the teams alternate where they play in this small league competition. And what you can see is that there's no trend. Obviously, 1,000 is what the teams will stay at, since that's what they're set at, and they're equally weighted. And so you see that there's not too much variation. I should say that the black line is with an adjustment factor big K of 5, the red line a big K of 10, yellow line 20, and the blue line 40. So there are some deviations, mainly up here, but even the biggest adjustment factor only deviates 10 points away from 1,000. So that wouldn't lead to much of a difference in terms of any outcome predictions generated.
Oh dear. Okay.
Oh, who's that? Is that you, Rob?
Sorry, something just interrupted me. Sorry about that. I should have muted myself.
I guess I didn't check. I often mute people when I'm the one hosting the talk, so I've not muted anyone. So please do check if you're on mute or not. And I'll try not to take it as a comment on my presentation. This would be the probability of the home outcome. And so with the setup, assuming a slight home advantage in two equally strength teams, the true probability based on the numbers generated from the Poisson distribution is about 44%, and you can see that the forecasts are about 44% throughout. Of course, in the real world, team strengths change, and so another tentative simulation, I generated that the team strengths change, and so what I've done here is after 200 matches, I've changed the team strength. so that team one becomes considerably stronger. And again, I've done this based on goal arrival. So I then chose goal arrival parameters in the Poisson distribution such that it was consistent with the team being about 200 Elo points stronger. And so what you can see is that it doesn't, the Elo ratings don't quite achieve 1200, but on the other hand, the goal arrival rates are also consistent with Elo strength differences of this magnitude as well. So I suspect I'll develop the simulations a little bit better as we go along, but this shows something that's perhaps intuitive from thinking about the adjustment factors, which is that the larger is your adjustment factor, the faster would your Elo strength adjust, your Elo rating. And so the blue line with a big K of 40 adjusts very quickly within, I guess, 20 or so matches. Whereas with the K of 5, a very small adjustment factor, that's taking a long time to adjust, hundreds of matches. And of course, a football season tends to be 50 or 60 football matches. And so that's a long time for an adjustment to a change in a team strength. And this is what it might mean in terms of probabilities, where we do get a bit more of an idea of the true probability because we're generating numbers from a Poisson distribution. And you can see that the quicker adjusting K of 40 does adjust to a higher probability of the home team, of team one winning when they're at home, but doesn't quite adjust up to what it should actually be. K of 20 does, but it takes some time, and the lower K's again take a longer period to adjust. Okay, so that's a simulation approach, which I think can be illustrative, and so I plan to develop that a little bit further. But back to the empirical approach to evaluate. There are other potential tweaks as well that people have proposed over the years for the Elo system. One is that adjustment after each game, whether the team wins or loses, it might be also a function of the goal difference in the match. And this is a specification suggested by Vatum and Answer in their paper, where you have this as being the function of the goal difference. You add the adjustment to the team that won and you take it away from the team that lost. And so we have the absolute value of the goal difference raised to this lambda parameter. So that the bigger is the goal difference, the bigger is the adjustment factor. Another suggestion is that home advantage. So I mentioned the home advantage already, and obviously there's plenty of evidence for the home advantage. We might add in a factor that works the home advantage into Elo ratings. And so this factor H, simply added in to the calculation of the Elo ratings, would give you a home advantage. Of course, you've got to work out what that H is. And then I guess in principle, there must be ways to do it empirically. But you would factor in some kind of home advantage and calculate the Elo ratings given this home advantage. Other things to say about tweaks. So in terms of that adjustment factor, with some matches or some contests, some participants getting higher or lower adjustment factors. The time in the season may be interesting. Obviously, with the chess proposals, you had the players that were entering the game would have a different rating to those that had been in the game for a long time. And just as league standings can be misleading at the start of a football season, so it might be that Elo ratings are. If Elo ratings simply carry over from what they were at the end of the previous season, they may not be reflective of the new strength of a team in a new season because there's been between season adjustments in playing and coaching staff. And so what I will do when I'm calculating these Elo ratings over the history of English football is I will essentially for an alternative, double the adjustment factor. So if I as mentioned, I'm putting in 5, 10, 20, and 40, and I'll double that for the first few games of the season. So games that are in August and September for the English system. And then already mentioned the competition that a game takes place in. And some systems will weight up or weight down particular types of matches. And it appears that the idea is that cup matches are often seen as less important, and so therefore receive less of a weight. Particularly in more recent times, in a number of cup competitions, stronger teams will field weakened sides, and so it can be argued that these cup matches might not be the best reflection of the strength of the stronger teams. On the other hand, if we want to compare teams across different divisions in league structures, hierarchical league structures, or even compare teams across countries, say, then it might actually be that cup matches are more important for that purpose of calibration. So if going back to the this odd ranking of teams, if we actually think that Reading are only slightly better than Oldham, or that Oldham are better than Preston even, or better than Wayne Rooney's Plymouth Argyle, then surely it would be important to actually weight more highly the cup games, which is the competitions when these teams can all meet with each other. And then we see on the field what the outcome is between those teams. So another tweak, which I will do, is I will double the adjustment factor for cup matches. So again, I've got 5, 10, 20 and 40, and I'll double it for cup matches and see what impact that has. Basically, the idea being that cup matches are more important for getting a sense of the relative strengths of teams who are playing in different divisions from each other. In terms of evaluating forecasts, or evaluating the Elo ratings, I'll essentially use forecasting methodology to do that, because these are forecasts, and we get forecasts of football matches that then happen. So we use the outcomes and we compare them to the forecasts, and we will look at, for at least some of the time, we'll look at forecast errors. So essentially the difference between what happened and what we predicted to happen. A very simple calculation is the mean forecast error. Simply calculate the error for all of the football matches that we've got, and calculate the mean of that error. And if it's non-zero, that suggests that you've got a biased forecast. It's forecasting too high or too low in some direction or another. Of course, it could be that we have forecasts that are unbiased, but they're very erratic. So it could be that those with a higher adjustment factor, the variation around the true strength is really big, and that means that forecasts are quite wild, but unbiased. And so the mean squared forecast error, often also referred to as the Brier score, is simply the squared forecast error. So it cancels out those errors, and it's also intuitively a measure of the variance of forecasts. How varied are they? Another common way to evaluate forecasts is to think about the efficiency of forecasts. So does a forecast, when it's being made, use all the available information? And if it is the case, the forecast errors should be mean zero with a constant variance, which is what's been set out here for the error in this regression in equation 10, where the regression is a regression of the outcomes on the forecasts. And if alpha is 0 and beta is 1, then in expectation, the outcome is equal to our forecast. And this is often referred to as a Mincer-Zarnowitz regression test. And so we'll do that for efficiency. A different way of writing that is to think about it in terms of the forecast error. So essentially subtract the forecast from both sides. And in this case, we're then saying, well, is there anything predictable about my forecast errors? And what we'd hope is that alpha is 0 and beta tilde is 0 in this case, such that our forecast errors are indeed mean zero constant variance. And we could add extra information in there as well. So if we're thinking about evaluating the mistakes that Elo forecasts make, we could add in other information, the positions of the teams in the game, for example, as a simple way of checking whether there's other information that was available at the time that wasn't fed into the forecast that was made. And the final thing to do in terms of forecasting, which will be relevant later, not quite yet, is if we had more than one kind of forecast, which we will. We'll bring in bookmakers later. And if we bring in another forecast, we say we've got two forecasts now. We've got the first forecast with y hat is the forecast, and then y tilde is the second forecast with respective forecast errors. We can start to ask the question, which forecast is better, by saying, well, can one forecast explain stuff that the other one can't? Okay, so E hat, the forecast error for the first set of forecasts, That's the stuff that the first set of forecasts couldn't explain. These are the stuff that's left over, the variation left over that the forecast couldn't explain. And if beta 1 is significant, then forecast 2 is able to explain some of the stuff that forecast 1 couldn't explain. And obviously we can do that in reverse as well. We can ask, well, here's the things that forecast 2 couldn't explain. Are there aspects of the things that forecast 2 couldn't explain that forecast 1 can explain? And this approach is known as encompassing. And if it was the case that, say, beta 1 was non-zero and beta 2 was 0, that would say that forecast 1 can't help to explain forecast 2's mistakes, but forecast 2 can help to explain forecast 1's mistakes. And so in that case, we would say that that's this case, that the second forecast encompasses the first forecast. It has more information. There's nothing left of value in the first forecast that we'd really want, and so we'd focus on using the second forecast, and vice versa. But of course, it can be the case that both are non-zero, and in which case there's information in both to help explain. The other than is indicative that there's different information sets being used to form these forecasts. Okay, so thinking about those different parameterizations. So I said we were going to have a big K of 5, 10, 20, and 40, and a little K of 200, 400, and 800. Found the diagonals. These are exactly the same because they're equivalent cases to each other. And then we've got no additional tweak. We've got the August-September tweak, where we boost the ratings. We double them in August and September. We've got the tweak where we double in the case of cup matches. We've got the tweak where we use goal difference and the tweak where we add in home advantage. What you can see is that there's almost no difference between these. This is the Brier score, so it's a relative measure, but the only difference really, so if we look at 410, we've got 0.236 when we don't make any tweaks. We've got 0.235 when we use August-September, 0.236 again for the cup boost, 237 with goal difference, 236 with the home advantage. There's not an awful lot of variation here, which kind of suggests that at least at the very first pass, all of these different tweaks might not necessarily, at least on a forecasting Brier score basis, might not matter all that much. These numbers are all very similar to each other. This is when I ran an efficiency test. So I ran this regression on all of those different parameterizations. So in principle, the most efficient forecast has alpha 0, beta 1. So what I've plotted here is the intercept coefficient, that's alpha down here. And up here is the slope coefficient. So this is beta. And so based on efficiency, we might hope that we get as close to this point here, 0 for the intercept for alpha and 1 for beta. And excuse the text, which is not at all clear in terms of its legibility. The replications, also the variants that get closest to 0 and 1, with a big K of 10, a little K of 400, which is what is standard, and then cup games being given a boost. And you can't quite see it there, but another one that's very similar in its position is if games in August and September get a boost to the rating. So essentially, what this suggests is that K of 10 and the normal small K of 400 and boosting cup games, so that when teams play from different divisions, we get a better sense of what's going on. We adjust more the team's ratings for the outcomes of those games to calibrate between different competitions. And also we use August and September to allow ratings to adjust for changes in team strengths. So if we do that, and we assume that's our taken method, it will then be indicative to compare those Elo ratings to some of the forecasts. Just to quickly say that when we do this from here on, we're going to use Elo predictions. We're going to use an ordered logistic regression on Elo predictions to generate a forecast of the home win, because we're going to the probability of the home win, because we're going to compare to bookmaker prices. And of course, bookmaker prices are in terms of the home win, the draw, and the away win outcomes, and so we need to convert our Elo predictions. And what we do is we're using footballdata.co.uk betting prices, which begin in 2002. So we estimate an ordered logic regression on pre-2002 data and use those parameters to turn the Elo prediction into a home win, draw, and away win, which is essentially what I showed you right at the start here. So these probabilities were generated that way from this Elo rating prediction. Okay, and so then what do we get as a result? These are some summary statistics. These are the 68,000 odd matches that we've got in England and Scotland from the footballdata.co.uk website over the years. 43% of them were home wins, 26% were draws, and 30% were away wins. And then we can look, first of all, at the mean predictions. So the mean Elo prediction is 50% or 51%, so slightly higher than the actual outcomes in terms of draws. The draw 24% and the away win 25%. Bookmakers very close, 43%, 26%, 30%. And then this here is a league table forecast. So it's constructed by essentially throwing bits of information from the league table into an ordered logic model and getting a home win, draw, and away win forecast. And you can see that again, it's not too dissimilar from the Elo in terms of the proportions, the average forecast that it generates. So that's thinking, first of all, very simply about the summary statistics of these forecasts. We can think about forecast errors. So our bet book market, Bet365, we take just as one bookmaker that prices all these games. Essentially a zero mean forecast error, so no bias. Elo forecasts, slightly negative bias, and this league forecast, a slightly negative one. I don't know, I have to confess, what's going on here, because that's a very big number, and that also translates onto the next slide as well. So we'll ignore that line for now. There must be a bug somewhere along the way. But in terms of price scores, mean forecast errors, bookmaker prices ever so slightly smaller than Elo ratings and the league-based forecasts as well in terms of alternative forecasts that we could find. We might want to also ask the question, look at the question of efficiency. And I showed you what the regression looked like, the alpha being 0 and the beta is equal to 1. If alpha 0 and beta is equal to 1 and we plot that, that's what we get here. This is essentially binning forecasts by where they forecast an outcome to be. So maybe 60% or the 60% was the forecast for the home win. And if therefore forecasts at 60% turn out to be the case 60% of the time, we get plots on the 45-degree line. And this is despite all, what you can see is basically is lots of points very close to the 45-degree line. The blue ones are all Elo forecasts. You can't really see them because they're all there. The red ones are Bet365 forecasts. And then we've got some of the league-based forecasts. The league-based forecasts don't ever predict much more than 70% or less than 30% for a home win. And there's a bit more of a range for predictions for the other forecasts. But they're all pretty close to being efficient. And that's what these numbers also say. So Elo forecasts, looking at them all or looking at them post-2002 when we essentially, we estimate the parameters up to 2002 and then we look at other games afterwards, so it's actually a forecast. They're pretty close to constant being 0 and the beta being 1. Bookmaker forecasts are over here, and they are also quite close. This small deviation from 1 is indicative of favourite long shot bias, which has been found lots of times in the literature. But we've got there essentially efficient, close to efficient forecasts. The final question, which I mentioned earlier on, is about encompassing. So is there more information in one set of forecasts relative to the other? Can we regress the Elo forecast errors? And will we find that there's information from other sources that help to explain the Elo forecast errors? And what we've got here is that the league forecast errors are significant. So that does suggest that there's some information over and above in the league standings that helps to explain the things that Elo forecasts can't make. And same's true for bookmakers as well. And then vice versa, our forecast based on league while the other two sources of forecasts can help. And the final, probably the most arguably difficult test, given the results in the literature over the years that I've not cited on the efficiency of betting markets, is whether league-based forecasts can help explain the errors that betting forecasts make. The answer is that they can't. So this league-based forecast is the positions of teams, the points they've got, the goal difference that they've got. So basic numbers taken out of the league table and turned into probability of a home win, draw, and away win by an ordered logic model. The Elo forecasts, on the other hand, are significant at explaining the bookmaker errors. So what that means is that, perhaps unsurprisingly, the bookmaker forecasts encompass our league forecasts, but they don't encompass our Elo forecasts. So our Elo forecasts can explain some of the things that bookmaker forecasts can't explain, and bookmaker forecasts can explain some of the things that Elo forecasts can't. So in terms of this comparison, obviously, so far we've looked at different parameterizations and settled on the idea that these the cup boost and the early season boost could be useful, could be effective. We've also found that a relatively low adjustment factor with those boosts might be most effective in terms of parameterization. And what we found is that they're not, these forecasts are not encompassed, and that they're all fairly efficient, and they've generally all got fairly comparable forecast errors. I suppose it's worth just saying that if we want to compare teams from different divisions, we should probably look just at the games in those cup competitions. And so I showed you the efficiency regressions for Elo forecasts. Elo forecasts, when we've turned them into a probability of the home win using the ordered logic model. And then it's probably worth also looking at just cup matches. And so this final column here is looking at the efficiency test based on just cup matches. And so what you can see is that there's no real change. Alpha is very close to 1. Alpha is very close to 0, and beta is very close to 1. And also the light, so this kind of lasery blue is the other cup forecasts. In other words, they're indistinguishable from the league forecasts, and that suggests that, well, it gives some idea that there might be some credence in these rankings, because they're producing ratings where teams from different divisions are nestling amongst each other. And then when those ratings are used to predict matches between those teams, the predictions seem to be pretty good. And so that might mean that we can think about comparing divisions that aren't in the same competition. And so what we've got here is 4 different divisions. We've got League One in England, the 3rd division, which is red, and then League Two, which is green, the 4th division, and the National League, which is blue, the 5th division. We've also got the Scottish Championships for the 2nd division in Scotland. And we start in the late 1970s. At which point the Scottish Championship is better than all of the English divisions. Then over this time period, the Scottish League has stayed pretty steady, Scottish Championship, to the extent that it's become, at least based on Elo strength terms alone, it's become inferior to the English 3rd division. And it's even become comparable to the 4th division and the 5th division in England. Another aspect of this is that this blue line is the 5th division. And when it was formed, this division didn't have promotion to the Football League. So the teams in this division, this blue division, couldn't get promoted to the division above, which was this one here, League Two, which based on Elo ratings alone was inferior. Okay, and then in 1986, promotion homologation was established. So the Football League became an open league. It stopped being a closed league. And then what you see is that the level in League Two has increased over that time period, and now they are relatively comparable to each other, which on an empirical basis stacks up. Lots of the teams that move from the 5th division to the 4th division do very well in the 4th division, end up in the 3rd division. Wrexham is the most recent example of that, or the most famous example of that. And if we think that these are a useful system, we can extend that comparison further back. We can think about league competitions that are in principle equal to each other, but regionalized. So below the fifth division in England, competitions become regionalized. It often happens earlier in other countries. But it happens in the fifth, sixth division in England, and used to happen in the third division. And when it did, the South Division was consistently stronger than the North Division. They were eventually just turned into four divisions, and obviously the fourth division was weaker than the third division. And then we still see here this fifth division effect, where eventually it starts off stronger, but eventually the fourth division catches up with the fifth division. Final thing that I want to spend a little bit of time talking about, and my apologies if you attended a talk I gave in the summer in Duisburg on this. Nothing too much is developed on this, but an idea, if we want to take Elo ratings a bit further, if we think that they're a good metric of team strength, and that's an advantage of Elo ratings over using, I think, bookmaker prices. You'd have to infer what the bookmaker thinks each team's strength is, and that's quite a bit of a process, whereas you've got an Elo rating. And if you think that that's a decent measure of team strength, then we could potentially use that to think about what that implies for the players that are playing in that team. So we could think about splitting up a team's Elo rating into the constituent parts for each of the players in that team. And there are other methods of rating players, of course. Ian McHale has done quite a bit of work on that, different ways of looking at players, the Castrol Index and things like that over the years. And there are many online platforms that do that as well, particularly assisting football clubs with their recruitment. So this is by no means a novel idea. Some of those rating systems rely on huge amounts of data. And one of the potential advantages of this system might be that it relies on relatively small amounts of data. I listed everything that's required back at the start. And so the idea is to split up that Elo rating to the players, and then track the players essentially over time and see what the resulting ratings look like. Also aggregate up the player ratings in each team, starting lineup, to give an alternative Elo forecast for a match as well. And so what we say is, well, we've got this adjustment that we've been talking about so far for a team. We say, well, let's split that up and give it to the individual players that we're playing. We'll give it to them based on how many minutes player J played for team I. And then we'll also split it up such that players that score goals get more of the adjustment. Players that get yellow cards get less of the adjustment, and players that get red cards get less of, of the adjustment as well. We could also add in, and I do for now, and this the parameters here, the big C, big R, big Y, and big G are just things that I've set completely arbitrarily, but we could think about trying to calibrate them better. But we can add in a clean sheet criterion. So this can be a part of the adjustment that goes to defensive players. If the team keeps a clean sheet, players get some proportion, an additional proportion of the adjustment if the team keeps a clean sheet, and that adjustment goes to the defensive players. A lot of systems, a lot of standard ways of evaluating players, goals scored, assists, and so on, favour more attacking players, and so this is a way in which we might favour defensive players if that's deemed important. And so we split the adjustment up such that the adjustment to each player sums to the total adjustment for the team. And then we can start to think about player Elo ratings. So just for just for simplicity, I've just called them R star. So player J has got R star JT, and that would be his rating that gets adjusted by his part of the team adjustment for each match. Okay, and so if we're starting to think about a player Elo rating, the player has to start somewhere. We could start them all at 1,000 over 11, given we start teams at 1,000 over 11, but we might want to start them at different levels for where they start at. A player that starts his career at my team, Oldham, in the 5th division, maybe he should start at a lower Elo level than Phil Foden starting his career for Manchester City in the Premier League, for example. And so one way to do it would be the starting rating for a player to be the team's Elo rating at the time that they make their debut, their first game, divided by 11 for the 11 players taking part. And so then we can get player ratings, and then we can construct player aggregated team ratings. So for each starting lineup, we add up each player in the starting lineup's Elo rating, and we get an alternative forecast. And excuse me, getting a phone call. Nice, get rid of it. So what we can say is that obviously if the team's personnel doesn't change, they play the same 11 players week after week, then their sum of their player aggregated team Elo would be the same as their team Elo, because their team Elo is calculated based on the team results. The player aggregated is based on the players, the starting 11 that's playing for them. If a team strengthens, then we can imagine its player aggregated Elo rating will be higher than its Elo rating. It's got better players than the results have suggested so far. And if a team is losing its best players, then its aggregated player ratings will be less than its team rating. Okay, so we can do that, and then we can get player Elo ratings. And so here are a scattering of footballers, some of them you'll have heard of, some of them you probably won't have heard of. So we've got Harry Kane, Virgil van Dijk, Jordan Henderson, and James Milner in there. And these are all the guys that have appeared doing well. There's a couple of other players down here who have been successful players in the lower divisions. So James Norwood scored lots of goals over his career. He's now ending his career scoring goals, thankfully, for my team, for Oldham. Dean Lewington has been playing for a very long time for MK Dons, and obviously forging a very successful career to be playing for as long as he has. And there's no reason to read too much into these sets of player ratings, other than that they do reflect the fact that these two players throughout their careers have played at the lower division level, and these players have been playing at the top level throughout their career. And arguably, well, I don't know, see, arguably Harry Kane and Virgil van Dijk are still going, whereas obviously Jordan Henderson and James Milner are very much in the twilights of their careers. And as mentioned, we can sum up to get player aggregated team Elo ratings to compare to plain old Elo ratings. And I'll take you back to my team again. This is just the Elo ratings since the year 2000, and the blue is the team Elo rating based only on the team's results, which shows the decline that the team suffered up to 2022 and the subsequent rebound that's hopefully ongoing. And then the orange line is the player adjusted. Now at the moment, that's by and large higher than the team Elo rating. So that's either indicative of the team continually recruiting players from higher divisions to try and fit in and improve the team, and or the fact that that team taken together is not performing perhaps as well as its individual parts might suggest. And so that's another potential way of thinking about making use of these player aggregated team Elo ratings, perhaps, to think about the extent to which a team is or isn't performing, the synergies between players, and so on, that we might be able to think about, rather than just simply is a team simply the sum of its parts. I've talked about ways in which to evaluate these forecasts. So the final thing to do is to say, well, are these forecasts from these player aggregated Elo forecasts, player aggregated team Elo forecasts, are they any good? And so we've seen this already. This is just the plain old Elo ratings based on match results for teams. And then we've got 3 columns here for the player aggregated team Elo ratings. Simply, if we set each player to start at 1,000 over 11, so we're not allowing Phil Foden to be better than Will Sutton, who's a player who plays for my team and started at my team. And club Pat Elo Club allows the adjustment to be different, so Phil Foden gets his higher rating than Will Sutton. And then we could also do it based on division as well. So if we thought that club might be a bit too specific, we could take the division's mean Elo rating at the point at which a player makes their debut and use that. Now, if you use either of the ways to control for the league standing and the ability of the club and the division it's in, we get better Elo ratings on the basis at least of the beta coefficient in terms of the efficiency test being a lot closer to 1. We can also ask, and that's quite big, isn't it? We can also ask, do our player adjusted Elo ratings help to explain the errors of other rating systems? And again, the answer is here is yes. So here's the Bet365 forecast error. And the player if the team Elo ratings comes out significant, it helps to explain things that Bet365 was unable to explain in its forecast for matches. There's no encompassing taking place here. There's lots of stars because the same's true in reverse. But the point is that there's this approach would suggest that there's information, there's informativeness in these ratings for making forecasts, and there's informativeness in the player Elo ratings over and above the plain vanilla Elo ratings for thinking about betting, or for thinking about match outcomes, I should say. Okay, so wrapping up, I think. Yeah, there we go. Conclusions. Missing the title the whole time. This has been an in-depth examination of Elo ratings, thinking about the parameterization, thinking about different tweaks to the ratings, and thinking particularly about the way in which we might evaluate teams in different divisions, and therefore players playing in teams in different divisions. We've therefore spent a bit of time thinking about the matches between divisions, and the suggestion that the ratings seem to do a reasonable job, that they're informative, that they're reasonably efficient, and that the errors aren't too out of line with other established ways of forecasting. We've then developed the idea of player Elo ratings, where players are given a particular amount of the team adjustment, and that appears to have some use, and that might be useful for many economic purposes, such as the way in which teams may think about and approach the recruitment of players and the retention of players as well, for that matter. So my apologies for running a little bit over, but I'll stop there and I will quite happily take any questions and comments. I can share my screen. Ah, Rob, there is a hand up. Go on, Rob. Can't hear you, Rob. Maybe you mute yourself after earlier on.
Hi, James. That was really good, especially the player part at the end. I find that very interesting. As you know, I mean, websites have composite player ratings already. There's the Who Scored rating, for example. And I've always worried about that the range of values is actually quite narrow, from about 6.5 to 8. And even if you're spectacular, then you get an 8, and then a load of other guys get sort of 7, 7.5. Would your system be able to be sort of compared with the Who Scored metric or other metrics that are composite, and would you be able to get a preferred metric out of that?
Well, I mean, I think it's a really interesting question. I mean, one of the interesting things, of course, about the Who Scored ratings is that they're based on Opta data. So they're based on extensive in-match information, which is not any kind of information that I'm using when I'm doing this. And I think that's a really interesting comparison to see how the two would look, because, again, what I'm thinking about a little bit when I'm doing this is I'm thinking about making these kinds of decisions when you don't have access to that level of information, up to stats bomb type data. It doesn't exist below the National League. And that might be a factor if you do want to find the next Jamie Vardy, as people always talk about. And so, I think it would be really interesting to have a bit more of an investigation of the Who Scored ratings and other equivalent ratings that are based on that extensive in-match data, and it would be really interesting to see how they stack up related to rating systems that are based on something much more basic like these ones, or plus minus ratings, or something else that you could calculate very simply based on match outcomes. So I haven't done that, and it's definitely something I'd like to do, and I think that's a really interesting potential development. Thanks, Webb. Any more questions and comments? Raphael.
Yeah, hi. Thanks, James. Very interesting talk. My question is about something that you shortly picked on up regarding the plus minus ratings that already exist, right? And they use basically the same level of data, right? So you don't need more in-play data. And my question would be, do the new Elo player ratings basically outperform these ratings, or how do they compare to the plus minus player ratings that we already have using the same data, basically?
Yeah, that's a really good question. I'm trying to think whether I did that direct comparison because I calculated plus minus ratings, the same code that I'm creating these, since it's based on the same information as you say. I didn't look back at them this time when I was preparing for this talk, but it is an obvious thing to do. You could probably sum up the plus minus rating for all the players and then calculate a relative prediction based on the relative size of the pluses and minuses for the two teams taking part. I looked at there's a paper, Show et al., which had a kind of an adjusted plus minus rating system. When I calculated them myself for the data set, there seemed to be quite big jumps at different points. If a player came on for 1 minute and 2 goals were scored, this kind of thing, there could be quite big jumps in those ratings, which meant they looked a bit odd in places. But that strikes me as something that you could quite easily resolve, I think, by weighting things down or ignoring those kinds of really big adjustments or capping them or something. But yeah, I think it's something that I want to do is see if this way of rating players does provide anything different or any kind of improvement on the plus minus ratings.
Thanks.
Thanks, Raphael. Any other questions and comments? It seems not. So thank you very much, everyone. Obviously, I'd be delighted to get any comments folk have offline as well, emails, messages, etc. I mentioned last week the WhatsApp group for the Roses talks. If you want to be a part of that and you're not already, let me know. I will add you to that group. And obviously, YouTube for previous talks will always be going up. Sorry, recordings of previous talks will go up on YouTube as well, so you can watch this back at a later point in time. Next week, we will have James Smoglia from Tufts University presenting Is the Swift Effect Fact or Folklore? A quasi-experimental investigation into Taylor Swift's influence on American football performance. So an interesting talk for next week, and I look forward to seeing many of you then. Thanks once again, everyone. See you all soon.
Thank you. Bye.
Cheers. Bye-bye.